The God particle. Sounds terribly impressive and lofty, doesn't it? Scientists all over the world are terribly excited and tantalised by the discovery of a new particle by their colleagues at CERN, the European Centre for Nuclear Research. But what is the Higgs boson? And have they really found it? Seanie Morris is in studio from the Midlands Astronomy Club. Seanie, good morning.
Morning, Will. How are you?
I'm very well, thank you. Higgs boson, I don't know what it sounds like, but the God particle I can maybe get my head around. Yeah. What does it mean?
Well, I tell you what we're going to do is we're going to talk about the Higgs boson, like the scientists at Geneva, at CERN there, make you think they know what they're talking about, because I was reading up on this for months now, ahead of the apparent discovery still to come. How would you say, the mind-boggling information that is out there. It is unreal. Trying to get your head around particle physics, that's easy enough, okay? Electrons, protons and neutrons, that makes up matter.
Yep. All right? That's easy enough.
Then you've got
easy.
Then you've got fermions, muons, gluons. You've got quarks, neutrinos, and then you go even subatomically smaller again, and you could hit upon the Higgs boson.
You're showing off now. So it's something really, really small.
Now, yeah. There'll be a little quiz on this a little bit later on, so make sure you pay attention.
Okay, well, if it's so small, why is it so important?
Well, did you do physics in school?
No.
No. Okay, well, physics will teach you that everything is made up of atoms, okay? Matter, molecules, everything you see around you is made up of atoms. The thing is that most atoms apparently are made up of 99.9% space, okay? There's this huge space between the nucleus and the electron that spins around the nucleus made of protons and neutrons. The thing is that, in theory, then we should be able to walk through walls, fall through the earth, things like that, okay? But it doesn't happen. Therefore, there's this mass that must exist. But where does it come from? There must be an underlying finite beginning point at which all this matter was created to be given mass for things to exist. And that's what scientists, since the 50s, with the discovery of the subatomic level of the atom, have been trying to find out what is mass. There is this thing that they have called the standard model of the universe. Everything is made up of atoms and pieces of atoms and smaller particles of those pieces of the atoms again. Where does it come down to that one point that would cure the mystery of, if the answer is the universe, what is the question? And that actually is the title of the book that the God particle came from. Leon Lederman.
By the way, can I interrupt you? And I am just about following what you're saying.
Yeah, you're looking a little bit red in the face there.
If you can reason that something is there because matter has mass, why is it so important to find it?
It's why go into space? Why 500 years ago set sail by going west instead of east? You know, it's all about the quest for discovery, to understand more. It's just the exciting prospect that there's something there, let's find it, you know? No one's going to get this massive paycheck for discovering the God particle or the Higgs boson. But it's going to be nice to know that we have the technology to say we can theorize that these things exist, let's go and find them. And then you've got the reward at the end to say, bang, there you go. This is how existence happened. And now, naturally bring up more questions.
The title God particle, and I know it's only a nickname, but it infers some proof of the great creator. Does it really?
No, this is a misnomer. In 1993, the Nobel Prize winner Leon Lederman wrote a book called The Goddamn Particle. If the universe is the answer, what is the question? All right? Now, the publishers said they didn't like the idea of him using this little piece of profanity and said, shorten it to the God particle, that will sell more copies. That's what he did. So the book in 1993 was called The God Particle. If the universe is the answer, what is the question? That's where the God particle...
So there's no religious value to this discovery at all?
No, there isn't really. The Higgs boson is what it is technically called. So...
Because it was theorized by some guy called
Peter Higgs. In the 1960s. Peter Higgs headed a team whereby they wanted to find the answer to the theory that there is this fundamental finite block that creates everything that we see today. And it wasn't until yesterday that we had almost distinct proof that the Higgs boson exists. And even at that, it's not necessarily a particle per se. There's the theory that the Higgs boson is an energy field that occupies space and attracts other subatomic particles to it to create mass. So it's not necessarily one particle per se, but you're looking for the existence of it because these other particles would be attracted to it.
Dick Ahlstrom was writing in the Irish Times today saying everyone knew it was going to be big, internationally important, historic even. And certainly if you watched the press conference, all of those scientists seemed very, very excited and happy with themselves.
Yeah.
Is it historic? Is this groundbreaking?
I'd say it would. Think of, how would you say it? Our society, is on the backbone of scientific discovery. Computers, the petrol engine, the rocket, anything. It's all based on a scientific premise that we can create this if we can, put these things together, these molecules, you get the transistor. With the transistor, you get smaller circuits. With smaller circuits, you get computers who could do work for you.
Sure, but there's usefulness and application to all of those discoveries.
There is all of that discovery.
This is something we were pretty certain existed in some form. We just couldn't see it or measure it or quantify it.
That's true. But I think my angle is that us as humanity, to say that we're a flesh and blood creature, we can think for ourselves, we create, and now this whole discovery of creating new things or discovering new things, to say that we could do it. We could actually find the fundamental reason why these particles exist. And over, since the apparent Big Bang theory of the creation of the known universe, all these molecular structures have existed. Then you get chemicals, then you get chemical bonds into DNA and into life and organisms and if sentient beings like us. That would be the summit of the mountain to say, we have done it. It's kind of like a humanity thing that, we're here and this is why.
Why is there a slight health warning on this discovery? Why are they not absolutely certain?
Well, like I said, yesterday was almost conclusive proof, right? They still need to do some more tests. Now, these tests range in 600 million collisions a second are happening all the time at the Large Hadron Collider. Now, they need to keep doing a few more tests to make sure that the results that they got are conclusive, that they can replicate it and get the same results. And that would say, okay, these results, the results of these collisions are showing the properties of what the theories have said since the 1960s would indicate the existence of the Higgs boson. All right? There are two independent labs at the Large Hadron Collider, and independently, they both came up with the same value. And that was to say that one wasn't tampering with the other wasn't copying the other's experiments or results, and conclusively got the same result to say, bang, we got it.
This isn't the same place where they thought they'd broken the speed of light and their measurements were off.
No, that was in northern Italy. Actually, it was between Switzerland and Italy. There was a detector in, I can't remember the place, but it was in Italy, where this beam of neutrinos were fired from a location 252 miles away, I think it was. An incredible distance. But what happened was that between the actual signal and the particles that were also sent simultaneously, the particles, the neutrinos, arrived that very, very tiny but measurable amount sooner than the beam, the energy beam, which could be light or radio or so on like that. So that was to say that the neutrinos had actually travelled faster than the speed of light. And it did happen back in the late 90s in a lab in the States where they put it down to a fault in their equipment. But now that it happened a couple of months ago again, and they're trying to replicate that again to see, can the speed of light be broken, that would also probably would be another momentous scientific discovery.
If it's true.
If it's true. Neutrinos are so small. There will be millions having passed through you, me, everyone in this building, the whole Earth, and they won't interact with a single atom as they pass through. They're so small, they're almost undetectable. And their usual characteristic is derived from the explosion of a shooting star or a massive cosmological explosion somewhere in the universe. So
you asked me a few moments ago if I studied physics. I presume you did.
I did.
And what grade did you get?
I obtained a C2 in honours physics back in 1996.
A C2?
C2.
You've improved since then, I would imagine, or should we just discard everything you've said?
No, it's pretty true now, everything. And I have to say, I have a few facts for the Large Hadron Collider in case you'd like to know.
Absolutely.
This is a big machine, right? It's a tunnel in the Earth about nearly half a mile down below ground.
Yeah, basically they whack particles together at massive speed.
They do. And this big tunnel that does it, it's 17 miles round trip. Okay, that tunnel was built. It cost £2.6 billion sterling to build. They have 9,500 magnets that hold the beams in place as they go in this circle around the 17-mile trek, okay? Those magnets are super cooled to minus 120 92 degrees Celsius by 10,800 tons of liquid helium. Liquid nitrogen, right? Then when it gets that cold, they use liquid helium to get it down to